Today, I want to talk through the Arena inventory example file. After watching this video, you should be able to create something like this from scratch. And I've also provided a few graphs and some other items, which should help you understand what's going on here a little bit better. Let's go ahead and get started. So this is one of the Arena examples files. You can find other videos like this on YouTube and watch more of them if you're interested in finding some like this. And you can open them yourselves by going to File and then Browse Examples. I want you to focus in here on the green elements right here and watch what's going on here with this logic and the supply and the demand side. As you can see, this is a simple inventory example, and Arena has some mumbo jumbo here about how a simulation can be better than a standard spreadsheet because it accounts for variability, which is true, and then some other stuff which I'll get into in a later video about the enhanced visualization and using Arena Visual Designer. Okay, let's go ahead and take a look at the model here, the string block diagrams, what this is actually doing. So we do have two different create modules, and let's go through the supply side first. What happens is we have an entity that's created with a random exponential time between arrivals here, or just a random, right here, with 1 hour being the most likely one here. So it's one entity per arrival. It's pretty standard. Max arrival to 1, first creation 0. It's a standard create module with exponential right here and a value of 1 hour. After this thing is created, which will happen every hour, roughly, it goes through an increment, which is an assign module. You've likely seen these in some of the other videos I've made, but this one has a few differences from the standard bits. So for instance, right here, we are incrementing 4 different variables, and these variables are stored in a variable array, which is a one-dimensional array. And we have 1, 2, 3, 4. We have inventory 1, inventory 2, inventory 3, and inventory 4. We're going to see these essentially looped through with a row number, and you can refer to a specific instance here by doing the inventory of 1 with parentheses like that. So for instance, the first assignment will take the V inventory of 1 and add 10 to it. So every time there is a supply entity that shows up, the inventory 1 is increased by 10. Same thing for the second. It's actually identical 1, 2, 3, 4 right here. So for V4 inventory, every time a supply entity shows up, 10 more is added on to that one. And by the way, it starts at a default of 0. So that's what the first assignment is doing. It's essentially creating new inventory, which we're going to do something from. And after something arrives, it goes through a delay module, which is a triangular process right here with a unit of days. So it takes a very long time for more supply to actually be created here, which is kind of interesting and mimics the real world a little bit. So that's our supply side. So every, let's say, approximately 4 days, we get an additional 10 units of supply. Taking a look at the demand, we have a demand entity, which is random time right here with a mean value of 1 hour. So that's the same as the supply. So it's a kind of an interesting item right there. Now, the first thing we have is actually pretty complicated on the demand side, and that is decrementing, which is the opposite of incrementing for demand right here. So what you can see, and this will make more sense when we take a look at the different items I've added, is that we have the variable array, which is again that one-dimensional V inventory array. The first row is going to be equal to what the first row previously was. That's again x equals x plus 1, x equals x minus 1, and we're taking away a value that's triangular between 1, 2, and 3. So every hour, we're taking away, let's say, 2 units of demand, of supply, etc. So we start with 10 usually, and then every hour here, we're taking away 2. There's a delay at the end, so we'll get back to this one, but notice that this is a smaller impact here than that initial spike of 10 of demand, so you could see something like that if you look at a graph of inventory over time. And the same thing is true for inventory 2, inventory 3, and inventory 4. We're taking away a triangular item right here with a mean value of 2, and it's done in the 4th row for the 4th one, and etc. And the other thing we're doing is we have a variable called vrow, which we're going to use later, and we're assigning that to 1 every time something comes through here. It's assigned to 1. We're going to deal with that just a little bit later. So that's great. We're now decrementing for demand and doing something with that vrow. What we're going to do initially is then send this through a decide module right here. What this does is if the variable in vrow, so the first time we loop through, we're going to check the inventory of the value of vrow. So for the first time, it will be the inventory of 1 because row is initially set equal to 1. And if the inventory of 1 is less than 0, that means that it's a negative value and we have a stock out. You can't sell something if you don't have it in inventory right now. So then we go through and we add a stock out and penalty, which gets pretty complicated. So let's go through this step by step. So first of all, the stock out just counts. V stock out, how many times do we have a stock out? Well, it's equal to whatever it previously was plus 1. We're doing this right now for the first row because the value of V row is still equal to 1. So we set that equal to the number of stockouts. We should see that increase by 1, by 2, by 3 for that particular variable. We also have lost revenue for that particular item. So again, the lost revenue for item number 1 in row 1, if there's a stock out, will be equal to whatever it was plus $100. So that's something that you can do right here. We also have the inventory right here, so we're going to set the inventory of that row is equal to 0, because again, you can't go less than negative. So if we were to graph this over time, we might see some negatives initially, but it would bump up to 0 within essentially the next time step right here. So that will go and set inventory to 0, because like I said, you can't have negative right here, unless you had something on back order, but that's not the case in this model. So, and lastly, we have the V total lost revenue, which is a different array than V lost revenue. This is just going to, does not matter. There's no row item in here, as you can see. So if the value of V row is 1, if it's 2, if it's 3, if it's 4, it doesn't matter. This will be equal to whatever it was plus $100. And that's it for the assign module right here. After the assign module, we're going to go through and right now, remember the value of V row is 1. We're going to take the done checking module right here, which will check if V row is exactly equal to, or just the double equal sign is equal to 4. If it's true, we'll do something and we'll come back to that. If it's not, we're going to go down to the increment row counter right here and say V row is now equal to V row plus 1. We're done checking the first row. Now let's move on and check the second row. So we'll go through, and that goes very back to the decide if negative value right here, where we look at the second item in the inventory, check if it's negative. If it is negative, we're going to give a stockout penalty and go through the done checking again. Now we're on the third one and going through the third item. We again check if it's negative. If it is, we give it a penalty. If it's not, we skip directly to done checking, and same thing for the fourth one. By the time the fourth one gets to done checking, we'll see if it's exactly equal to something. If it is, which it's always going to be eventually, because again, we're checking 1, 2, 3, 4 times with a 0 simulation time between that as it comes through, now we run into delay 2. Remember, delay 1 was set to a mean of 4 days, and then actually it's a little bit different than that because it's the most likely value of 4 days, maybe the mean is something like 4.5. The delay 2 right here is going to be 1 day. So notice that the demand happens much more frequently than the supply, although the demand is larger than the supply, being at 10 units every time. So fixed or not, or that would be stochastic. That would be deterministic, I'm sorry. And then the demand is stochastic. We don't know this one. It's going to be triangular with a mean and most likely value of 2 right here. So 2 versus 10, but one happens 4 times as quickly as the other. So we still should come back down to 0 eventually. But now that we understand what's going on here, let's take a look and watch the entities go through here. I've also gone through and grabbed some different items which might be useful to take a look at while you're looking through the block diagrams. I think that it's useful to put these, let's say, right next to the block diagrams. So what these are is these are variable counters that just counts the value of the inventory of 1, 2, 3, 4, which you can make really easily. All you have to do is type in the inventory of 1, and that will show you the current value of the inventory of 1. So let's go ahead and take a step through and see what happens right here. As we take a step through, we're going to get to the create step, and nothing too crazy is going to happen yet. The supply entity is created, and it goes through the increment process right here. So this variable, all of these are assigned the value of whatever they were previously plus 10. That's fantastic. So taking another step forward here too, we're going to go through until something changes with the numbers or the entities down below here, is now we've hit the demand. So the demand entity has been created, and we are decrementing for demand. Demand again will be equal to, it's a triangular distribution, so we should see that values between 1 and 3 are subtracted off of these current variable counts right here, or the inventory counts, which they are. So as you can see, it took just a little bit, 1.5 from 2 of these, and then 2.7 from this fourth one. So if that happens again, 2.7 will be the first one that runs out. But at this point, we actually do need to run through the entire process here. So if you were to watch this kind of step by step, and I'll go ahead and slow this down all the way and press run, you'll see the entities are moving through the checking. They're checking, so it's on the first row number, it's now the second one. It's checking the second row number, it's not negative, so it goes to the third one right here. The third one is also not negative, so it goes through and adds that, makes it now number 4, and that goes through until we get through the fourth one. It's done checking, and now we're on day 2, so I'm going to see what happens here. So once this actually goes back to day 2, you can see we had another demand instance right here where we have demand for these 3 items, and as you can see, number 4 is still the lowest. It's going to go through and do the counting and making sure that none of these are negative, and they're not, so it's going to skip immediately to the next delay and then the next decrementing for demand, which is what it's going to do right now. So we should still be okay, things are not going to go negative yet. But by the time we reach the next one right here, so if we speed this up a little bit, and we're on the, let's see, there we go. We have no negatives yet, but the next one right here, this 1.56, is looking pretty low. This is likely going to be negative next time, so let's go ahead and speed that up just a little bit. And we can see that, yes, we saw a negative for the first value. It was then reset to 0. We're going to see a negative for the second value, which is reset to 0. The negative for the third value is not negative, so it's not going to be reset to anything because it's still positive. And the last value here will get set to 0, and then we're going to go through another demand cycle right here. Unless we have the supply come through first, which we don't, we now have 4 different negatives, and these are all going to continue to happen like that and get set back to 0 every time. And the stockout count is actually going to be triggered every time by the stockout and penalty until the create supply entity comes back through. So we saw that happen now, and we're incrementing everything. They're back to 10, and the process is going to continue over and over. Now, actually, on the left here, and I'm going to scroll over or maybe zoom out a little bit, you can see that there are some of these numbers that are shown on the left side here in what Arena has given you. It does actually have the current variable inventories. I just find it more useful to where you can see both of these going on at the same time. So that's something to think about there. It's got the current inventory values, but if you're watching the block diagrams, you might want to look closely here. You can also look at the number of stockouts. The expected value will be the same for all of them, but again, due to the stochasticity, there is going to be some differences in those right here. As you can see, lost revenue is equal to the stockout count times 100, and total lost revenue is the sum of the stockouts count times 100, or just the sum of the lost revenue. I will note that it's not explicitly defined as the sum of the lost revenue. It's just every time there's a stockout, $100 is added. It's slightly different. You could totally do the same thing if you wanted to. Now, a natural question for you here might be, what's going to happen with the inventory over time as time progresses as we go towards infinity? And for something like that, a graph of the inventory over time might be useful. So let's go ahead and pause the simulation and stop the simulation, which will happen once it gets through the checking value right here, and then reset this. So are we going to do better or worse as we go towards infinity? I'll let you think about that for a second, based on the fact that there is a supply of 10 every 4 days or so, and then the demand is 4 every, I think, demand is 2 every 1 day, which would correspond to over 4 days, it would be a demand of 8 compared to a supply of 10. So think about if this is going to go higher and higher, or if it's going to stay back towards 0, because remember, we do get reset towards 0. And I'll go ahead and replace the Arena examples right here with the graph, and the graph, I'll show you how to make this after I show it to you, is going to show inventory over time for these values right here. So as we run this, we're going to see that we do have initial values right here, and well, I guess we're partway through, so I should reset this before I show it to you. So I'm going to reset this and then play it again at a relatively slow speed. We're going to see that we have these values that are being graphed here. They're all on the left side, and they start at 10 initially and are slowly going to drop. They're going to drop to negative values, which are below 10, and then get reset to 10 the next time a supply run hits. And that's going to continue. I've graphed these all using slightly different series and colors and dots and dashes, but you can't really tell what they are because the expected value and the actual value are very, very close to each other. For the actual values, expected value is the same. And what you can see is that the supply runs end up coming quickly enough that we actually have a positive value. At this time right here, we were reset back down to 0 for some of these, but you can see by the time we're at t equals, let's say, 50, it's likely going to be somewhere around here where we're going to actually have values that are positive and are staying positive. The supply run is going to hit when we still have units in there that are not demanded from previous ones, which you can see happened right about at the 35 time period mark, but then some drop below it at 40, and then by the time we get to 50, we can see that the supply is hitting when we already have units in stock. And then as we get towards the end of the replication length, this is going to reset. We're going to see the same thing over again. So that's just something to note. You can change that in the Arena run setup if you wanted to. The replication length, I've left it at the standard Arena example one that you've seen here. So what this tells you is that you don't have a lot of inventory very on, but a lot of inventory as you immediately get started. But as you continue on and go towards infinity and go to even just say a week worth into it, if you run this process at steady state, your supply should be more than good enough to cope with your demand, even if there's a lot of negatives and a lot of stockouts early on here. So if we were to graph the stockout time, or the stockout cost, we could also see that the cost and the number of events were very high initially, but the rate at which those occur gets lower and lower as time progresses. I do want to show you this graph and how I made it, so let's go ahead and reset this and then look at the graph. It's relatively straightforward. It's just a plot that I've added. I've added a data series where I've clicked on the expression and set this equal to be inventory of 1 and then be inventory of 2, 3, 4, etc. You can change the line styles and such if you want by scrolling down here and changing some of these. So this one is left solid, the second one I've changed to dashed, etc. And I've left them what the default colors are asking for. We also do have the axes, which I've turned on here and enabled a few different items, including grid lines. So you have the one where it was equal to 0. And then, of course, I did go through and added an axis label for time and an axis label for inventory, which are the X and Y values right here. And then I left the legend and everything else as is. So now you should understand this Arena model a little bit better. You should be able to make something like an inventory over time without your standard seize, delay, release process modules, just with a delay event and a supply event. And you should be able to understand how something like this works. Open up the example and play with it yourself. I will be making a future video on, again, the sneak peek bits that were mentioned in here. If you want to see that, you can check that out on YouTube. I hope you learned something useful about industrial engineering, and I'll catch you in the next video.